Okay, so we are living through the AI Big Bang. I mean, everything is getting an AI upgrade, right? From our apps to our cars, but this explosion of intelligence brings up a really fundamental architectural question. Yeah, where does this intelligence actually live? Is its real power locked away in these massive remote server farms? Or is the most important computation happening right there in your pocket, on the chip inside your phone? Now, this isn't just some philosophical question. No, it's the core conflict that's going to shape the next decade of tech. It really is a battle between two completely different philosophies: centralized power versus distributed intelligence. So, welcome to the showdown between our three main contenders: cloud AI, edge AI, and on-device AI. In this explainer, we're going to dig into the data. We're talking performance, cost, security, to figure out which model is really going to win the future. And let me tell you, the answer is way more interesting than you might think. All right, first up, we have the reigning champion, cloud AI. This is the big one. Here, the intelligence lives inside these enormous data centers. Its main job? The really heavy lifting of training. I mean, it's the only way you can train monster models like a GPT-5, which needs thousands of GPUs all working together in what they call petascale clusters. Seriously, think of it as a supercomputer for AI. Its strength is just raw, almost unlimited power and scale. Next in the ring, we've got edge AI. Now, this is our first step away from that centralized model. We're not talking about your phone just yet. This is all about bringing the computation closer to where the action is. So think local servers, network gateways, or hardware racks right there on site at the near edge of the network. The whole point here is to slash latency. You want to make real-time decisions in places like a factory or a smart city, and you just can't do that if you're sending every bit of data back and forth to the cloud. And finally, our third contender, on-device AI. This is what we call the far edge. This is where the AI runs directly on your smartphone, your car, your smartwatch. It uses these incredible specialized chips, like Apple's Neural Engine or Google's Tensor Processing Units, the TPUs. And because all the processing happens right there, locally, it offers two absolute killer features: maximum data privacy and the ability to work completely offline. Okay, so now that we've met the players, let's put them head-to-head. We're going to compare them across three absolutely critical battlegrounds: speed, security, and of course, cost. Round one is speed. And in the world of AI, speed really means one thing: latency. How long does it take to get an answer? And what's wild about this chart is just the scale of the difference. A request to the cloud can easily take 100 milliseconds, or even more. Why? Because the data has to physically travel across the internet and back. The network is always the bottleneck. But look what happens when you move to a local edge server. You cut that down to around 5 milliseconds. And then, on-device AI. Well, it's the undisputed champion. Latency drops to just 1 millisecond. It is virtually instantaneous. So here's the key takeaway. It's this fundamental trade-off, right? It's unlimited power at a distance versus limited power right up close. Cloud AI gives you all the brute force you could ever want, but it's literally limited by the speed of light. Meanwhile, edge and on-device AI deliver that mission-critical, split-second speed you need for something like an autonomous vehicle. But their power, well, it's constrained by the physical size and heat of the chip in your hand. Let's move on to round two, security. This is where things get really interesting, because your architectural choice here has massive ethical and even political consequences. With cloud AI, all your sensitive data gets sent to an external server. You're basically creating one massive, juicy, high-value target. A single breach could be absolutely catastrophic. But with edge and on-device AI, the data stays local, which is amazing for privacy, but the risk just shifts. Now you've got thousands, maybe millions of devices out in the world that could be physically stolen or tampered with. And this really illustrates the dilemma perfectly. For regulations like GDPR in Europe, keeping data local isn't just a good idea, it's a legal requirement. Edge AI solves the cloud's big centralization risk, but it creates all these new headaches around physical security and remote management. This is also, by the way, where cool hybrid solutions like federated learning come into play. That's a technique that lets models learn from all that local data without the raw sensitive data ever having to leave your device. All right, final round, cost. And this total cost of ownership chart tells such a fascinating story. Look at cloud AI. The entry cost is super low, which is attractive. But as you scale up, those operational costs just spiral out of control. In fact, a 2023 report from Andreessen Horowitz found that 53% of companies are overspending on their cloud bills. Now, edge and on-device AI are the complete opposite. You have this huge upfront investment in hardware, but then, over time, the operational costs are way lower, causing that cost curve to flatten out. So the financial trade-off becomes crystal clear. Cloud AI is kind of like a subscription service, right? It's easy to start, easy to scale, but it gets really expensive over time. Edge AI is more like buying a house. It requires a huge down payment. A high-end edge system can run you anywhere from $3,600 to $7,500. But you get these long-term savings. Some estimates show you could save up to 40% in annual costs. The big catch, though? It's way harder to update and maintain all that hardware once it's out in the wild.
So based on those 3 rounds, you might be thinking, okay, the choice seems pretty straightforward. But this is where the data reveals a twist, because those clean, neat numbers we see in a lab test, they don't always hold up in the messy reality of the real world.
Okay, so let's start with a foundational premise. According to the research survey Green Edge AI, supercritical systems, we're talking autonomous cars, augmented reality glasses, they need a response time of somewhere between 10 and 100 milliseconds just to function safely. If it's any slower than that, it's a catastrophic failure. This is the accepted theoretical safety limit.
But here's the conflicting data. A peer-reviewed benchmark from a paper called Empowering Edge Intelligence went and tested a bunch of these models running on actual mobile devices. And the inference time for a common model like Inception v3, a staggering 1,537 milliseconds. That is more than 15 times the maximum safety threshold. This just blows the whole thing open. It reveals a fundamental conflict. Even when you're on device, real-world performance can totally violate those theoretical safety limits. It proves that just moving to the edge isn't some magic bullet for speed.
So, if no single architecture is a perfect solution, where do we go from here? The data isn't pointing to one clear winner. You know, these extreme scenarios where the cloud totally dominates by solving latency with 6G, or where the edge completely takes over because of privacy laws, they just seem less and less likely. Instead, all the signs are pointing towards a cooperative, hybrid future.
And look, this isn't just some theory we cooked up. According to Gartner, the choice isn't cloud or edge. It's cloud and edge. This chart pretty much says it all. By 2027, they're projecting that over 80% of enterprise AI workloads will be running in some kind of hybrid form. The battle was never about picking a winner. It's about building intelligent orchestration.
And in this new hybrid reality, each architecture gets a specialized job. The central cloud becomes the training factory. It's really the only place with enough raw power to build these massive foundational models. Then you have the edge cloud, which acts as the orchestration hub, managing all the real-time industrial tasks and filtering data locally. And finally, on-device AI serves as the real-time sensor and privacy anchor, handling all those instant, personalized tasks where data absolutely must stay local.
So how does this cooperation actually work? Let's look at a really cool advanced technique called model splitting. So first, a tiny draft model on your phone quickly predicts the next few words you're about to type. Then, those predictions are sent up to the cloud. Step 3, the massive target model in the cloud verifies all those predictions at once, in parallel. Finally, that verified text is sent back to your device. The end result? A system that feels way faster and is much more energy efficient than a pure cloud or a pure on-device model could ever be on its own. It's brilliant.
So the huge takeaway here is that the future is all about distributed intelligence. It's a single cohesive system where each part just plays to its strengths. The cloud does the heavy lifting and trains the models. The edge orchestrates all the real-time industrial stuff. And your device? It handles the personal, the private, and the instantaneous moments of your digital life.
This quote just captures the entire strategy for the next decade perfectly. Train once in the cloud and deploy many times at the edge. It's all about using that immense centralized power of the cloud for the hard part, the creation, and then distributing that finished intelligence out to the edge for efficient, real-time action.
And this really brings the whole thing together. Let's go back to that transportation analogy. A high-speed rail, a local subway, and a personal scooter, they aren't competing with each other. They're all coordinated by an intelligent system to create the perfect journey, using exactly the right vehicle for each leg of the trip. That's the future of AI. That's synergy.
So in the end, the winner of this big architectural showdown, it's not the fastest chip and it's not the biggest data center. The real winner is the most intelligent orchestrator. That piece of software that can seamlessly route any job to the most appropriate, cost-effective, and efficient place in the system. Which leaves us with the real question. Are we building that orchestrator the right way?